Here's a brief introduction to JuiceBox software for use in multi-state and multi-organizational planning efforts. This video provides a technical description of the underlying modeling approach and assumes familiarity with resource models. JuiceBox is a resource planning tool, which means that it helps define objectives, examine alternatives, and evaluate system performance. JuiceBox is pre-populated with customizable data for the continental U.S. The U.S. can be cut into any subset of smaller regions. I'm using hexagons here just for example. The power sector model uses a load duration curve dispatch algorithm to estimate generation from each available power plant. This can be done for a single region in isolation, or a dual system approach can be used where a local system and a broader region are both simulated with an LDC model with a defined amount of capacity for the local generating units to exchange power with the broader market. These dual systems can further be networked together into integrated nodes such that planners from multiple jurisdictions can define plans and scenarios that interact with each other. This creates multiple approaches to represent a power market, as a single isolated system, or as a system where generating units can exchange power with the market, or as a network of systems with uniquely defined market access. The examples I will provide next will define a power market as a set of interconnected state power systems. I've set these examples up to roughly correspond to the NERC regions in this diagram. In this case, the Mid-Continent region is represented by 12 interconnected states that exchange power. This is an imperfect approximation of the MISO region, which includes parts of Canada and excludes parts of many states, most notably the Chicago region. Next, I will show some examples where we solve a projection for an individual state within a multi-state region. JuiceBox is a cloud-based multi-user platform. This means I can develop plans and scenarios that belong to me, and I also have plans and scenarios with shared access among a group. So within the Mid-Continent region, I've created a set of 12 state plans that are part of a single integrated regional scenario. I'll load a plan for Illinois. And what we see here are the generating units that exist in Illinois, color-coded by fuel type. So green is renewable, light blue is natural gas, dark blue is nuclear, and gray is coal. When I hit solve, each generating unit in Illinois is dispatched within this 12-state region, and the results are summarized at the bottom graph. These results are highly sensitive to fuel prices, and so we can look at the natural gas price. These can be user-defined, and these can be adjusted to create a more realistic dispatch. We can also look at individual generating units. Here we see a unit where sulfur dioxide in the simulation is much higher than it was in history. Likely there was a control unit added to this generating station. We can effectively visit the facility, look at the input parameters for this facility, and adjust them appropriately. So perhaps this unit has a lower SO2 emission rate due to a change in fuel type or the addition of a pollution control, and we can deal with that either way, either by updating the database, or if we prefer, we can install a pollution control addition at this unit. So far we've looked at the system configuration and data for individual power plants, but we haven't talked about the expansion plan. JuiceBox lets users define planning requirements and then monitors whether or not those planning requirements have been met. So in this case we're looking at the reserve margin requirement, and we see that it's satisfied in Illinois until about 2026. at which point this compliance monitor turns from green to red. In order to satisfy that requirement, we have to add generating capacity, from which there's customizable sets of power plants that can be added. I'll add 2,000 megawatts of combined cycle natural gas. Notice that on the planning reserve requirement is compliant for additional years now, but that new construction will be required in 2030. So importantly, JuiceBox does not build out the expansion plan automatically or using optimization. It's up to the user to define the sets of power plants, pollution controls, and energy efficiency that are used to meet planning requirements. So for example, I'll load another Illinois example. In this case, there's been new renewable additions, energy efficiency additions, pollution controls, power plant retirements, and the addition of natural gas units. Notice that we have planning requirements set for reserve margin, for renewable portfolio standards, for the Clean Power Plan, as well as targets for sulfur dioxide, nitrogen oxides. We'll also keep track of costs and average rate. And when we hit solve, we should see that the program will keep track of compliance with each of these planning metrics. Keeping in mind that the Illinois system and expansion plan is interacting with 11 other state systems and expansion plans as defined by the planning group.